Welcome everyone, my name is Alonzo De La Cruz and I'm the Senior Geomatics Engineer for Suncor Energy here in Canada. Today's talk is going to be the evolution of our custom coordinate systems in Geographic Calculator. First, a little bit about me. I've been with Suncor since 2012, and before that, I was in the field for a little bit. But at Suncor, one of my main responsibilities is to deal with any coordinate system and transformation issues that pop up. But an interesting fact is, with our custom coordinate systems, most of those were created before I even started. So something called living with history, living with those past decisions is required, and you'll see. So which area of the world are we talking about? Well, the project areas with our custom coordinate systems are in northern Alberta. Specifically, they're just north of a town called Fort McMurray. So you can look that up if you like to get a better idea. And each of these project areas, so each of those squares or rectangles that you see there, has at least whatever you want to call it. Custom coordinate system, plant grid, mining grid, engineering grid, local projection, you name it. It has at least one of those. And the reason we use them is that they're actually really useful and important at Suncor for the things we do. And I'll explain why. So let's look first at this orange rectangle here. This area here, you see this plant. This is one of our oldest plants at Suncor, if not the oldest. We call it the base plant. And it has a very unique custom coordinate system because it's one of the first ever created for our company. And it's so old, it's from the 50s and 60s, that it's from before Canada adopted the metric system. So it's actually in feet, which makes it quite unique. And you'll see why we built it. Let me explain why we use these custom coordinate systems in general. First, the numbers are smaller. I want you to think back to the 1950s, 1960s, what work was like back then, especially for surveying, construction, a lot of this geospatial work. You didn't have computers, less likely a digital calculator. You didn't have GNSS. A lot of surveying was still done with chains back in those days. So you needed a coordinate system that fit the area that you were working with. That was essentially localized to the area. It needed, in this case, it was oriented to fit the direction of the river. Its numbers are smaller. The false easting and false northing are in the tens of thousands, rather than with a UTM zone in this area has the northing in the millions and the false easting in the hundreds of thousands. With less digits, less likely you're going to make an error, easier calculations. And finally, a scale factor was chosen that fits the ground in this area. So what that means is a unit of measurement in the custom coordinate system or in the plant grid matches a unit of measurement on the ground. So essentially a foot in the grid is basically a foot on the ground. And so what happens if we say reproject this image that's projected right now in UTM zone 12 to the plant grid? You get this. Now all of a sudden you can see the layout of the plant grid. It makes a lot more sense. It's laid out essentially north-south. You can see how it lines up to the river. That's why they created it. Imagine if you had to account for that 30-ish degree rotation off north in every single one of your calculations as you're trying to lay this out. Didn't make a lot of sense. So that's why we create those plant grids in the past. And even now, with the computers and everything that we have, that scale factor is still necessary so that a unit of measurement in the grid matches a unit of measurement on the ground. And with some of these older ones, especially older custom coordinate systems, they have unique characteristics that can cause issues in other software. But coordinates in general can be a little complicated. See, with our work, because what we do is physical, we build on the ground, we extract the physical resource, we have all kinds of professionals and teams using geospatial data, and they aren't necessarily geospatial professionals. So things like datums, projections, elevations can be a little tricky. That's why we need Geographic Calculator, and that's why it evolved over time, because it's easy to use and it does basically everything that we need it to do. Now, before we jump to 2015, let me explain what happened when I started at Suncor. Calculator was being used before I even started in 2012, but when I started, it was very niche. There's only a handful of people that could use it, because while it did quite a bit, it didn't do everything we needed it to do. But in 2015, Blue Marble added an extremely useful format to both Global Mapper and Geographic Calculator. And to get an idea of what else was happening in 2015, Uptown Funk was the #1 song in North America, and Force Awakens was the top movie. So while you were singing along with Bruno Mars and cheering on Han and Chewie, we were celebrating Blue Marble Grids as they hit the scene. That's right. Blue Marble Grids allowed us to do everything we wanted to do in Calculator because Blue Marble Grids made the more complicated vertical conversions possible in Geographic Calculator. See, some of those older custom coordinate systems had a vertical component that was pretty tricky because it wasn't a simple offset, and it wasn't a simple offset and slope. It was a little more complicated than that. And we had trouble customizing Calculator until the grids came out. And once the grids came out, then all of a sudden we could do 3D conversions for everything at Suncor. So let's take a look at that area again. Let's take a look at these two, that orange, the base plant, and the red square, the base mine. The first two grids we built were for that. Here's the one grid. This grid goes from CGVD 28, Canadian Geodetic Vertical Datum of 1928, which we still use, to that base mine, so the red square. This one, you can see how it slopes in a different direction. This one goes from CGVD 28 to the base plant. And finally, this one goes from base mine to base plant. Now, you'll notice something about them. They're quite massive. Why did I make the grid so big? They do seem way too big because we've learned a very hard lesson over the years, and it's an undefeated rule when it comes to custom coordinate systems. They will always be used beyond their original intended area. It does not matter. I want you to think about our company. We have thousands of employees across North America doing all kinds of work with geospatial data that's in these custom systems. We can't police it. There's no magical boundary where we have to tell people they can no longer use these coordinate systems. So rather than being a bottleneck or trying to do the futile work of trying to police that, we have a different philosophy. We'd rather make it easier so that they can do any work that covers any reasonable scenario with those custom coordinate systems, so that they'll never come across a situation where they're trying to do a full 3D conversion and the grid doesn't cover it. That's why we made them so big. How do you make them? Well, pretty straightforward. First, you have to make a custom vertical datum. And second, you go to the transformations in your data source. You go to vertical, you click the plus button. See all those blue ones? Those are all the custom ones, all the custom transformations we've made. It brings up the dialog box. You give it the identifiers are name, code, etc. And in details, this is important. First, your source and target has to be right. You have to know from what's your source datum and what's your target datum, because your Blue Marble grid is also in that order. The delta z's are in that order. Second, your vertical offset file. You'll notice the vertical transform is Blue Marble vertical transform grid. You have to select that. So that brings up these parameters. You have your vertical offset file. That's the Blue Marble grid file that you make in Global Mapper. You give it whatever name, its format is .bgd. And lastly, the path. You can put the Blue Marble grid in any folder that the computer can read or the software can reach. What's really useful about that is it allows us to make any changes and updates to these grids without the user having to do anything on their end, because it'll just keep functioning the way they want it to. And we can just add the new grids or replace the old grids as needed. And their Blue Marble grids are super easy to make. In Global Mapper, you need to upload what's essentially an XYZ file. But rather than Z being the elevation, it's the delta Z. It's that difference from the source datum to the target datum. With positive means the change is going up, negative means change is going down. You import as a grid and you export it as a Blue Marble grid. And these grids now allow us to do transformations of all kinds of data in Calculator and Global Mapper. That's why they're so useful. And this is one of the reasons why Geographic Calculator has evolved in its use and popularity at our company over the years. What started as a handful of people using it prior to 2015 has now grown relatively company-wide because it can do everything they needed to do coordinate transformation-wise. But the evolution of Calculator didn't just end there with the vertical grids in 2015. There's been other things to help make it more popular over the years. Fitted systems. If you have to deal with custom coordinate systems, fitted systems are so useful, and they've really evolved over the years at our company. Here's just the list of the fitted systems we use, and we essentially make one for every one of those areas, those project areas I showed you earlier. And the reason they've evolved over the years, and the reason we make them, is this: they work exceptionally well on lists of 2D coordinates and CAD files. See, the beauty of fitted systems is that if you have the data, that transformation using the fitted system can be more accurate than going through a projection, especially for some of these older local plant grids, these older custom coordinate systems. Sometimes the projection is only accurate to that centimeter, decimeter level. But if you have the right data with the fitted system, that transformation is essentially at the millimeter, sub-millimeter level, thus eliminating any error in the coordinate conversion itself. That's why they're so useful for lists of 2D coordinates and CAD files. A little bit of history. Before I started in 2012, the company actually got Blue Marble to make our first 4 fitted systems. They gave them a list of control points, and each of those areas that you see on the screen represent the area covered by those control points. And they actually were really good. But over the years, we've expanded the area of the control points, increased the density of the points in the fitted system that we used, and thus we're able to increase the order of the polynomial so that it would be even more accurate. And fitted systems are useful in the following 2 scenarios. This is where they really shine. For those older coordinate systems where the projection, so the conversion through the projection has an accuracy at the centimeter, decimeter level. And what you want is a conversion at that millimeter, sub-millimeter level. See, depending on where you're using the data, the projection might start to lose some of that accuracy. So this is where fitted systems work really well, because they give you that expected conversion. And when you're almost exclusively just going between 2 coordinate systems, this has come up a lot lately, especially from a geographic or geodetic, so from a lat long to a custom system. They're great because you can just bypass going through a datum conversion or anything like that. You just create a straight conversion between the 2, thus giving you the exact conversion that you want. That's where fitted really shines. That's one of the really important uses of Calculator at Suncor. And here's a useful tip for you. 2-point fit projections are great when you have very little data. There's been a couple projects where we had almost no data to work with. We're talking a minimal number of points. And the 2-point fit projections worked really well to help us solve those issues. Let me explain. Here, let me show you a real case example of one that popped up for us. Again, look at the units, feet. So we're dealing with an old one, and we had almost no data for it. In fact, all I really had to work with was a control plan with 5 points attached to it. But they're super useful because, first, you only need 2 points. All you need is your easting and northing and lat long for 2 points. That's it, which makes them real easy to make. Second, they're really accurate. Calculator essentially takes care of the orientation, the scale, and the translation for you. So if you have very little data to work with and you need to make a projection that you can then use to export the data out into a more common projection or coordinate system, that's where they really shine. The only drawback is, as far as I know, they can only be used in Blue Marble products. So you can only use these in Calculator and Global Mapper. I kid you not, when I said all I had was a control plan with 5 points, this is essentially how the points looked. And what you do is you essentially use the 2 points that are farthest apart diagonally. This way you're having that longest length takes care of any issues in your scale, your orientation, your translation to make it really accurate. So if you ever have to deal with something that you have super little data with, a custom coordinate system that's really old, 2-point fit can really save you. Now, GeoCalc mode in GlobalMapper is what made Calculator a really important company-wide. A lot of people use GlobalMapper at our company. But the reason is not just because of all the formats that GlobalMapper can handle, but because through GeoCalc mode, it can read all our custom coordinate systems and transformations in full 3D. See, everyone who gets an install of GlobalMapper also gets Calculator so that they can use the Calculator library. You just turn on that button and it brings up everything that it's almost everything that you've made in Calculator. So here for a horizontal coordinate system, if you need to choose one of the custom ones, you click on the button there, and here you can see the list. And now it brings up the geodetic and the projected. Luckily, the projected are in blue. Anything you've created is in blue. For vertical, they're there as well. It brings up all the vertical systems, again, in blue, so that you can find the stuff that you created. And finally, the transformations. It brings up not just the transformations that you made, but also it can generate two-step transformations to bring in data using the Calculator library. And not just it for horizontal, but it does the vertical conversions as well, using those blue marble grids that we created earlier. So there are two key events that really took Calculator from a niche product that only a handful of us used when I first started in 2012 to being much more widely used, not just by geospatial professionals, but by non-geospatial professionals as well. One, when we could do the full 3D coordinate conversions. See, once we could do everything, Calculator is a nice software to teach to almost anyone because it's easy to learn to do the conversions. And two, when GlobalMapper was acquired and the GeoCalc mode was implemented. So it meant that that Calculator library of custom coordinate systems and transformations was available in GlobalMapper. These two events are what took Calculator from a niche product to much more widely used. All right, thank you for listening. I'll answer any questions now. In case you want, you can find me on LinkedIn here. Thank you very much.